Elon Musk's latest decision may have revealed Tesla's real future, and it is not cars. The new AI5 chip was expected to power robotaxis, but Tesla quietly sent it to Optimus Gen 3 instead. With massive factories already being prepared, many believe Tesla is about to start a robotics race the world is not ready for. There is a harsh truth about intelligent robots that most companies refuse to admit openly. They are not actually smart when operating on their own. The majority of today's AI robots run on a cloud-dependent model. The robot collects data from sensors. It sends that data to a central server. The server processes it and sends back commands. The robot executes them. That model sounds reasonable until the network connection becomes unstable, until the server gets overloaded, until the factory Wi-Fi gets interfered with. At that point, the robot cannot do anything at all. In an industrial manufacturing environment, that is completely unacceptable. An assembly line brought to a halt because a robot lost its network connection means losses of tens of thousands of dollars every hour. But there is a second problem even harder to solve: power consumption. For a humanoid robot to handle complex tasks in real time, it needs a sufficiently powerful chip. The most powerful AI chips currently available, such as NVIDIA's H100, consume over 500 watts of power continuously and cost $30,000 per unit. A humanoid robot's battery typically holds only 2 to 3 kilowatt-hours of capacity. If the chip draws 500 watts, the robot will drain its energy in fewer than 6 hours. And that figure does not account for the motors, the sensors, or any of the robot's other systems. In practice, the robot would not be able to operate for more than a few hours. That is why no one has managed to build a truly autonomous humanoid robot at industrial scale until now. Not because of a lack of ideas, because the hardware problem had no solution. Tesla just found that solution. Tesla just made a decision that reveals everything about where robotics is actually heading. The AI5 chip is finished, designed, complete, ready for manufacturing. And Elon Musk chose not to put it in cars first. Not in the cybercab. Not in the upcoming robotaxi fleet. The AI5 chip is going straight into Optimus Gen 3, the humanoid robot Musk believes could eventually become Tesla's most important product. Elon Musk described AI5 with very specific numbers. Compared to the AI4 generation currently used in Tesla vehicles, AI5 is 8 times more powerful in computing performance, 9 times greater in memory, and 5 times faster in data bandwidth. A single AI5 chip delivers inference performance comparable to NVIDIA's H100 while consuming only around 250 watts of power, roughly half the power draw. That number changes everything. At that efficiency level, Optimus Gen 3 can operate through an entire workday inside a factory while processing everything locally, without depending on Wi-Fi or cloud connections. What makes AI5 different is Tesla's design philosophy. NVIDIA builds chips that must handle many different workloads for many customers. Tesla stripped away everything it considered unnecessary and focused the entire chip on running Tesla neural networks as efficiently as possible. It is the same strategy Apple used when moving from Intel processors to Apple Silicon. The result is a specialized chip Musk claims delivers massive performance at a fraction of the cost of traditional hardware. But the real advantage may not even be the chip, it is the data. Before Optimus ever stepped into a factory, Tesla already possessed one of the largest real-world visual datasets on Earth through more than 4 million Tesla vehicles driving globally. Over 8.2 billion miles of real-world driving footage. Sunlight, rain, darkness, highways, tight streets, unpredictable obstacles, all processed into neural network training. No robotics company can easily replicate that. Boston Dynamics, Figure AI, Agility Robotics, and Unitree all have to build robotics datasets largely from scratch. Tesla starts with billions of miles of visual understanding already accumulated over years. Then Tesla added another layer, Engineers recorded factory workers performing real tasks, lifting components, balancing loads, moving through tight spaces, handling objects naturally. Instead of programming every movement manually, Tesla feeds human behavior directly into training systems, so Optimus learns by observation, much like a child learning by watching adults. Tesla is pushing this even further. The long-term goal is for Optimus to learn directly from internet videos. In theory, showing the robot a tutorial video could eventually allow it to understand and perform the task itself. That capability is still under development, but it reveals how ambitious Tesla's plans actually are. The training itself may be the most impressive part. Optimus does not primarily learn in the real world. Tesla has built what it calls a neural world simulator, confirmed by Tesla VP of AI Ashok Eluswamy in late 2025. Unlike traditional simulations based on rigid program physics, this system is trained on billions of hours of real-world video and generates highly realistic scenarios with changing lighting, moving objects, and unpredictable situations. Inside that simulated environment, Optimus can fail, retry, and improve thousands of times faster than in reality. No damage, no safety risks, just accelerated learning at enormous scale. Then comes Tesla's biggest advantage of all, the fleet flywheel. Every Optimus robot operating in a factory continuously collects data from the real world. That data is uploaded, analyzed, and turned into improvements for the shared AI model. Those updates are then distributed back to the entire robot fleet through over-the-air software updates, exactly like Tesla vehicles today. One robot learns how to solve a difficult problem, and shortly afterward, every robot knows how to solve it. As the fleet grows from hundreds to thousands to potentially millions of robots, the speed of learning increases exponentially. More robots generate more data. More data improves the AI. Better AI enables more capabilities. More capabilities sell more robots. That cycle compounds over time, and Tesla believes that is the foundation of a long-term robotics advantage competitors will struggle to catch. But there are still major realities that cannot be ignored. Elon Musk himself admitted during Tesla's Q4 2025 earnings call that the Optimus robots currently operating inside Tesla factories are still largely there for research and data collection, not yet for economically valuable production work. Many headlines talk about 1 million robots by 2027, but manufacturing 1 million robots is very different from deploying 1 million highly capable human-level workers. There is also the timeline issue. AI5 only completed design work in April 2026, with engineering samples expected later in the year. The Optimus robots operating today still rely on older hardware. Large-scale AI5 deployment inside robots remains a story for 2027 and beyond. And Tesla is far from alone. Boston Dynamics brings decades of robotics experience. Figure AI has backing from Microsoft and OpenAI. Agility Robotics has partnerships with Amazon. Chinese companies like Unitree are already producing humanoid robots at dramatically lower prices than Tesla's projected Optimus cost. Tesla may possess a massive data advantage, but competitors still hold strengths in affordability and commercialization speed. Still, Tesla appears to be playing a much longer game. Chips can eventually be copied, robot designs can evolve. But billions of miles of accumulated real-world data, combined with millions of robots learning together around the clock, is much harder to reproduce quickly. That is likely why Tesla prioritized AI5 for Optimus instead of cars. AI4 is already capable enough for Tesla vehicles today. Optimus, however, needs AI5 to accelerate the autonomous learning loop as fast as possible, because once that flywheel reaches scale, it may become extremely difficult for competitors to slow it down.